Subtopic 3.2 Absolute Values. In this subtopic, we'll talk about defining absolute values as well as stating and using the properties of absolute values. The definition of absolute values: if I have modulus A, and this modulus A will be equal to either A when my A is greater than or equal to 0, or negative A when my A is less than 0. Here my A refers to the A that is inside the modulus. In the first line, when my A is greater or equal to 0, A is positive. So modulus A will be equals to A, positive number. In my second line, when my A is less than or equal to 0, my A happens to be a negative. So here, this time in the second line, modulus of a negative number will be equal to negative. Here A is negative, so negative number. So here I have negative, negative. Here I have negative, negative. Negative, negative will produce a positive number. So that means that my modulus A will always be equal to A, where my A is always positive. Now we will talk about the properties of absolute values. So for number 1, modulus A, I'll change the property. Modulus A here must be positive. Say for example, if I have modulus 3 will always be 3. Modulus negative 3 will also always be 3. So it will always be positive. And another example, if I have modulus 0 is 0. So I have modulus A to be greater than or equals to 0. It must always be positive, and it also can be equal to 0. Now for number 2, if I have modulus 4, this is equals to 4. So modulus A will be equal to A. For number 3, let's say I have modulus negative 4. Modulus negative 4 will also be 4. So in this case, modulus negative A will also be A. If we look at property number 2 and 3, I can make a conclusion. Modulus A is equal to modulus negative A. Now we go to number 4. Let's say I have A equals to 2 and B equals to 3. So modulus A plus B will give me modulus 2 plus 3, which is equal to 5. How about modulus B plus A? Modulus B plus A will be modulus of 3 plus 2, which is also equal to modulus 5, which is also equal to 5. So by comparing and seeing these two, I can make a conclusion that modulus of A plus B is equal to modulus of B plus A. Now for number 5, we play with two numbers. I have A equals to 5, B equals to 1. So this time I have modulus A minus B to be equals to modulus 5 minus 1, which is modulus 4, which is 4. How about modulus of B minus A? Modulus B minus A will give me 1 minus 5. So this is modulus negative 4, which is also 4. If I compare them, I can make a conclusion that is modulus A minus B will be equal to modulus of B minus A. Now for example 6, property number 6. This time I take A to be equal to 2, B is equal to 6. So modulus AB will give me modulus 2 times 6, modulus of 2 times 6, which is modulus 12. And this is 12. How about modulus A times modulus B? Modulus A is modulus 2 multiplied with modulus B, which is modulus 6. Now modulus 2 is 2, modulus 6 is 6. So it will also give me 12. By comparing these two, I can write modulus AB to be equal to modulus A multiplied with modulus B. Now the last property, let's say I have A equals to 10 and B is equal to 2. So this time I have modulus A over B to be equal to modulus of 10 over 2. Solve what is inside, it will give me modulus 5, which is 5. How about modulus A over modulus B? Modulus A is modulus 10, modulus B is modulus 2, so modulus 10 is 10, modulus 2 is 2, so final answer I still get 5. Comparing these two, I can now write modulus A over B to be equal to modulus of A over modulus of B. For property number 7, take note that my denominator B cannot be equal to 0. Okay, my denominator b cannot be equals to 0 because any number divided by 0 is undefined. We will now take a look at some examples. So for number 1, modulus of negative 10 will always be positive, so it will be equals to 10. And for number 2, modulus 9 is still 9. For number 3, solve what is inside first. Pressing the calculator, you get negative 9 inside. Modulus negative 9 will always be positive, which is 9. For number 4, solve first. This is modulus of negative 3, which will always be positive, that is 3. Now for the last slide, our example number 5. Solve what is inside the modulus first. I get 9 to be inside the modulus, so this will produce 9. For number 6, modulus 4 is 4, modulus 6 is 6. These two are combined by multiplication, so my final answer is 24. And last example, modulus negative 5 is 5, modulus negative 1 over 25 is 1 over 25. They are combined by multiplication, so final answer 1 over 5.